If you remember, there are three forms to a quadratic function. We've looked at graphing vertex form. Yesterday we found out how to accurately graph in factored form. And now we're looking at standard form. Standard form is probably the most difficult one to work with because it doesn't give us any information when we look at it. There's no vertex, there's no zeros. We have to do the work to find all of this information. So remember, standard form looks like y equals ax squared plus bx plus c. A, b, and c are numbers. So an example of an equation in standard form might be y equals negative 3x squared plus 12x minus 2. Okay? So to find the vertex, we have to do a little bit of work. We've got an equation for the vertex, which is also the equation for the axis of symmetry. X equals negative b over 2a. So again, b is the coefficient of your x, a is the coefficient of your x squared. So for our example here, the axis of symmetry, or the x value to find the vertex, would be x equals, now this negative just means opposite. So the opposite of the coefficient for x, 12, divided by 2 times a is the coefficient of your x squared, negative 3. So if we were going to finish solving this, we'd have negative 12 divided by negative 6, giving us a positive 2. So that's the x coordinate for the vertex of this function. Then we would, just like with factored form, substitute that value back in to solve for x. So here's our first example. We've got y equals x squared plus 10x plus 3. So the first thing we're going to do is find this axis of symmetry. Same formula we just looked at on the vocab page. So we set up x equals the opposite of b, the coefficient of our x term, divided by 2 times a, which is the coefficient of our x squared term. Remember, if you don't see something that we're multiplying by 1, because that's the only value that won't change what we started with. So we've got negative 10 divided by 2, or negative 5. So that's the equation for the axis of symmetry. And then we, of course, simplified that expression. So to find the vertex, we've already got x equals negative b over 2a. We solved for x, so now we're going to substitute it back in to solve for y. Substituting negative 5 for x, everywhere we see an x. Negative 5 squared, remember squaring means multiplying by itself. So negative 5 times negative 5 is positive 25. 10 times negative 5 is negative 50 plus 3. 25 minus 50 is negative 25. Negative 25 plus 3 is negative 22. So the coordinates for our vertex, we got an x value of negative 5 and a y value of negative 22. The other thing we're going to practice that we will need in order to graph is our y-intercept, but we've practiced y-intercepts lots of times, substituting 0 for x and solving for y. So in this case, the first term is 0, the second term, 10 times 0 is 0, so this simplifies to y equals 3. So our y-intercept is 0, 3. Remember, we started by substituting 0 for x first. And I forgot to label this one. All right, next example. Again, starting with that axis of symmetry. X equals the opposite of b. So here's b. B is negative 6. The opposite of negative 6 is positive 6. Divided by 2 times a. This time the coefficient of x squared is negative, or negative 1. So we've got 6 divided by negative 2, or negative 3. So that's the equation for our axis of symmetry. Vertex, we take that value and substitute it back in for x. Now be careful here because our x squared term has a negative sign out front. We can't replace that when we're substituting negative 3 for x. So just replace the x, this negative sign stays there. Alright, and then using our order of operations, this negative sign is still going to stay there. Negative 3 squared, or negative 3 times negative 3 is positive 9. Remember, this negative sign right here is from that lead coefficient. Negative 6 times negative 3 is positive 18. Minus 1. Negative 9 plus 18 is 9. Minus 1 is 8. So to write our coordinates as an ordered pair, we got an x value of negative 3, y value of 8. Finally, we're going to find our y-intercept. Now, some of you may have noticed a shortcut when we found the y-intercept on the first example, and there is one, because those first two terms both have an x. Anytime you multiply by 0, you get 0. So when you're finding the y-intercept, it's the c value. The c is the constant, or the one term that's not being multiplied by x. So that's our y-intercept. Writing it as an ordered pair, 0, negative 1. And of course, we just need to see the process a couple more times. The equations are just having different coefficients, so seeing some different ways to work with numbers. All right, so starting with our axis of symmetry, we have x equals the opposite of b, or negative 12, divided by 2 times a. This time we have a coefficient that's not 1, substituting negative 3 for a. Negative 12 divided by negative 6 is positive 2. To find our vertex, we're going to take that value and substitute it back into the function for x. Remember, just replace the x. None of those coefficients go away when you substitute that 2. All right, evaluating. Order of operations, exponents before multiplication. So in this first term, I'm going to square my 2 before I multiply it by the negative 3. So the negative 3 is going to stay there for a minute. 2 squared is 4. Anytime you have a plus or minus sign, you can keep evaluating. 12 times 2 is 24. Now we have to do our multiplication first. Negative 3 times 4 is negative 12. And then we have to add and subtract left to right. So negative 12 plus 4 is 12. Minus 8 is 4. So the coordinates for my vertex, we've got 2 for x, 4 for y. And our y-intercept, we're going to do our shortcut again. The y-intercept is the one term, the one value that does not have an x being multiplied by it. So our y-intercept is negative 8. Writing that as an ordered pair, we substituted 0 for x to get negative 8 for y. All right, one last example. Of course, we have to see one with a fraction. So let's see how this works. I'll go through this math very carefully so you see what we're doing here. All right, so x equals opposite of b. The opposite of negative 2 is positive 2, divided by 2 times a, the coefficient of x squared. In the denominator, we have 2 times half, or half of 2, which is 1. So we get 2 for the x value for our axis of symmetry. Substituting that value back in to solve for the vertex. Substituting 2 for x. Everywhere we see an x. 2 squared is 4. So again, we have to do exponents before multiplication. Second term, we can go ahead and multiply those 2's. Half of 4, or half times 4, is 2. And then adding and subtracting left to right, 2 minus 4 is negative 2, plus 9 is 7. So we get a vertex of 2, 7. And finally, solving for that y-intercept. This is our easy one. We get to look at that shortcut. In this case, the only term not being multiplied by an x is 9. So our y-intercept is 0, 9. And your U-try problems.